This is a new chapter on mensuration. The chapter is on cylinder and cone. You must have done in class 9 a chapter on mensuration where you must have discussed about cubes and cuboids. Okay. This year we are going to do about cylinder and cone. The chapter also includes spheres, but that is excluded in the reduced syllabus. So we will not be doing spheres. Okay. So it deals only with cylinder and cone. Okay. The first figure is cylinder. These are all three-dimensional figures. Okay. So the first three-dimensional figure is cylinder. Imagine a cylinder. This is the cylinder. Okay. Now when you talk about cylinders, these are closed cylinders. Like say you take a piece of iron rod. Okay. If you take a piece of iron rod, it's in the shape of a cylinder and it is sealed everywhere. The top and the bottom both are sealed. Okay. So we are talking about solid cylinders, not open cylinders. Okay. So this is a solid cylinder. It's sealed from top here and the bottom is also sealed. Okay. And this is the circular part. Okay. Like say imagine this is a cylinder. This circular part is this portion, and then the top is in the shape of a circle, bottom is also in the shape of a circle. Okay. Now for a cylinder, this distance from here to here is called the height, which is represented with a small h. And if you look at this figure, the base or the top of the cylinder, it actually looks like this, which is a circle. So if it is a circle, this becomes the center of the circle. From the center of the circle, if you draw a straight line to touch the circumference of this circle, this length is called the radius, which is represented by a small r. So from the center of the circle to the circumference of the circle, this length is the radius. Same thing. Okay. Radius, which is small r. Now there are a few things that you have to know about a cylinder. That was the height. It's also called the length of the cylinder, and this is the radius. Okay. Now the first formula that you have to know for a cylinder is its volume. Like say for example, this is an iron piece, solid iron piece. How much of iron is there inside this will give you the volume of this cylinder. Okay. So volume generally is given as area of the base. This is the base. Okay. Area of this base. So when I talk about the base, it is like this. So when I say area of the base, this is the base. The area of this base, which is in the shape of a circle. Okay. So area of the base becomes the area of this circle. So this is the base, which is actually a circle. So volume is given as area of the base into the height of the cylinder. So when you talk about area of base, as I said, area of the base is actually the area of the circle. So this is area of circle into the height of the cylinder. Area of circle formula is pi r squared. Area of circle is pi r squared. That one is the area of a circle. Okay, pi r squared is the area of the circle, and the height of the cylinder was small h. So that's the small h which is here. So area of base, which is pi r squared, into height is small h. Multiplying this, you will get pi r squared h. Pi r squared h. Okay. Where pi's value is given as 22 by 7. In some questions, you may find values of pi which is given. Usually pi value which is given is 3.14. That will be given in the question. If it is not given in the question, then you will take pi value is 22 by 7. So that is a constant value. Pi value is 22 by 7. R squared into h. Now imagine the radius and the height both are measured in centimeter. Okay. So this is r squared, means r into h. So if radius was measured in centimeter, so this will be centimeter, r into r, which is also in centimeter, and height is also in centimeter. So centimeter into centimeter into centimeter, which will give you centimeter cube. But if the height and the radius was measured in meter, then this will be meter into meter into meter, which will give you meter cube. So generally the unit used is unit cube. Either it can be centimeter cube or meter cube or any other unit cube. Okay. So generally I have written it is unit cube. So volume is usually measured in this unit cube. Okay. So that's the first formula that you have to know. The second formula is curved surface area. Now if you look at the cylinder, there are three surfaces. One is the top surface, which is flat. Second one is the bottom surface, which is also flat. There is a third surface like this, which is circular. Okay. So this is the curved surface area. This portion is the curved surface area. If I consider this is the cylinder, all around this is the curved surface area. These two are flat. Only this portion is curved. So curved surface area in short is CSA. CSA, curved surface area, is given as perimeter of the base. Again, when we talk about base is in the form of a circle. Okay. So perimeter of the base, which means perimeter of the circle, into the height of the cylinder. Okay. So perimeter of the base means perimeter of the circle, which means this length you have to find, which is actually circumference of a circle. Circumference of a circle. This length is called circumference of the circle, which is given by the formula 2 pi r. It's given by the formula 2 pi r. That's only the perimeter. Perimeter is 2 pi r into the height of the cylinder, which is h. Okay. So that is the perimeter or the circumference of the circle, 2 pi r into the height of the cylinder. So 2 pi r h is the formula for curved surface area. We're talking about unit. Again, if radius and height both were measured in centimeter, then 2 is a constant which doesn't have any unit. Pi is a constant which is 22 by 7, that also doesn't have any unit. R, radius, is measured in centimeter. Height is also measured in centimeter. So this is in centimeter, this is also in centimeter. Centimeter into centimeter gives you centimeter square. If this was in meter, this was in meter. Meter into meter gives you meter square. So generally the unit is unit square. So volume usually is measured in unit cube, and here this is area. Area generally is measured in unit square. So that's the curved surface area, only this portion. Now, the third formula that you have to know is the total surface area. Means, first see how many surfaces it has. This is one surface, the top surface. This is the second surface, bottom surface. And the third surface is this one, curved. Okay. So, it has three surfaces. Add all the three surfaces, that will give you total surface area. In short, TSA. So this total surface area is actually three surfaces area here. One is curved surface area, so CSA, plus there are two circles which are here, which are flat. Okay. So add the area of two circles, this surface and this surface, two circles are there. Okay. So curved surface area, that is this portion, and 2 times area of the circle. One circle and one more circle. Two circles are there. Okay. So total surface area is curved surface area formula you already know, that is 2 pi RH that I have written here, plus 2 into area of circle. Area of the circle is pi r squared. So pi r squared, that much is the area of the circle. This 2 is this, right? Area of circle is pi r squared. So 2 pi RH plus 2 pi r squared. In these two, if you see, 2 is common, pi is common, 1 r is common. I removed all of them. So what is left here is h, and from here 1 r is left. So 2 pi r times h plus r unit square. You are finding area. Therefore again unit should be unit squared. So these are the three formulae that you have to know for a cylinder. Okay. So we'll go to solving questions. This is from exercise 20A, question number 6. This is the question. Two solid cylinders with radii 5 cm and 10 cm. There are two solid cylinders. Two cylinders are there whose radii means this is the plural of radius. Singular is radius, plural is radii. So these cylinders have radius 5 cm and 10 cm. First cylinder has radius 5 cm and second cylinder has radius 10 cm. And length 7 cm and 5 cm. Length here means height. Okay. Length here means height. This means height. So height of these cylinders are 7 cm and 5 cm respectively, which means the first cylinder has height 7 cm, second cylinder has height 5 cm. Are melted. These two cylinders are melted and recast into a cylindrical disc. A cylindrical disc is also a cylinder. Two cylinders are there, both of them are melted together and you get a single cylinder. Now about the cylindrical disc that you are getting of thickness 3 cm. Thickness of the cylinder means height of the cylinder. Okay. The third cylinder which you are going to get, okay, has thickness 3 cm, means height of the cylinder is 3 cm. Calculate its radius. So for the third cylinder you have to find how much is its radius. I have drawn figures for this. Look at it. Two cylinders are melted. This is cylinder 1, first cylinder. This is the second cylinder. First cylinder has radius 5, radius R1 I have written. Because everything is a cylinder, so you cannot use the same radius for everything. Okay. So for the first cylinder, the radius of the base I have considered R1 is 5 cm, radius is 5. And for the second cylinder, the radius is 10. For the second cylinder, radius I have written is R2, which is 10 cm. And their heights are 7 and 5 cm. The first one has height 7 cm, which I have considered as H1. And the second cylinder has height 5 cm, which I have considered as H2. Okay. These two are melted and made into a single cylindrical disc. This is the cylindrical disc, which is also a cylinder. So this is a new cylinder that you are getting. These two are melted, you get this. Okay. For the cylindrical disc, the thickness is 3 cm, which means the height of this, which I have considered as capital H, is 3 cm. And you have to find its radius. So I have considered the radius of this new cylinder to be capital R. For this, R1 is the radius 5 cm, H1 is 7 cm height. For the second one, radius is R2, height is H2. And for the new cylinder, I have considered the height is capital H and the radius is capital R. Now, these two were melted and made into this. So there should be something which is same between these two and this one. Okay. This much metal is melted and made into this single one. Therefore, volume of the metal which is used here should be equal to volume of the metal that you got here. Okay. So the relationship now is volume of the first cylinder plus the volume of the second cylinder should be equal to volume of the new cylinder that you got. That's the relationship. You will always write a relationship first. Okay. So the relationship that I have written is volume of cylinder 1 plus volume of cylinder 2, volume of cylinder 1 plus volume of cylinder 2 should be equal to volume of the new cylinder. After writing this relationship, substitute by the formula for volume. Volume of cylinder formula is pi r squared h. Okay. but this is for cylinder 1. So formula is pi, r is r1 squared, and height is h1, plus volume of cylinder 2 is again the same formula, pi r squared h, but it will be pi, radius is r2 squared into h2, should be equal to volume of new cylinder, again it's a cylinder, so formula is pi r squared h, pi, but now radius is capital R squared into height is capital H. Okay, we've written this. Then from this step, if you look at this on the left hand side, there is a pi which is common, I have removed. So see what is left, r1 squared into h1 plus r2 squared into h2 is equal to pi capital R squared capital H. You can cancel the pi on both sides, pi gets cancelled, and then substitute by the values. Radius of the first one was 5, so r1 squared is there, so 2 times here, right? Radius was 5, so 5 into height of the first cylinder was 7, plus radius of the second one was 10, but there is a square, so you will have to write twice. So R2's value is 10 into 10 for the square into height of the second cylinder is 5 is equal to capital R squared is what you have to find into capital H's value, the height of the new cylinder was 3. Okay. Simplify this. 5 is common. There is one 5 which is common. 5 and 10, 5 is common. Okay, so this 5 and this 5 is removed. So see what is left, that's 7. Plus 5 was removed. From here if you remove 5, 2 will be left. 2 into 10 is 20. Is equal to R squared into 3. That's the same. Again simplify this. That's 5 into this is 27. And the 3 comes this side. Divided by 3 is equal to R squared. Now to cancel. 3 and 27 goes 9 times. Okay. So R squared is 5 into 9, which means R will be square root of whatever is here. So square root of 5 into 5 and 9 I have written as 3 into 3. This is one pair, this is the second pair. You can find square root. Square root of 5 into 5 is 5. Square root of 3 into 3 is 3. So 5 into 3 gives you 15. All units used are centimeter. Therefore capital R's value is 15 centimeter. Therefore radius of the cylindrical disc, the new disc that you got, is 15 centimeter. Okay. That's the first question. Next. This is from the same exercise. Exercise 20A, question number 8. A 21 meter deep well with diameter 10 meter is dug up and the earth from digging is spread evenly to form a platform 22 meter by 15 meter. Determine the height of the platform. A 21 meter deep well is dug. Imagine this is the well that you are digging. Okay. It's a 21 meter deep well, means the height of this well is 21 meter. So I have considered capital H is 21 meter. Okay. With diameter 10 meter. Diameter means this whole length is 10 meter. This whole thing is 10. Therefore the radius capital R is half of this, that will be 5 meter. That's the radius and this is the height, okay, of the well. Now when you dig this well, you take out the earth, the mud which is taken out. It says this much deep well is dug up and the earth from digging, the mud that you get from digging, is spread evenly to form a platform 22 meter by 15 meter, and you have to find the height of the platform. So the platform that is going to be made is something like this. It's in the form of a cuboid. A cuboid having length, breadth, and that's the height. Okay. So this is the platform that is made. The mud which is taken out is made in the form of a cuboid. Okay. Now it says the platform is 22 meter by 15 meter. So 22 meter is the length. So small l I consider is 22 meter. That's from here to here. This is the length. And breadth is 15 meter. This much is 15 meter. Find the height. You have to find the height. So height is a question mark. That's what you are going to find. Now, if you look at these figures, whatever mud is taken out from the cylinder is made into this. Which means whatever volume was taken out from here is here. So the relationship is volume of this cylindrical well, volume of the well, which is in the form of a cylinder, volume of the well must be equal to volume of this mud which is taken out. Okay. So the relationship is volume of earth dug, whatever you are taking out from here, volume of earth dug is equal to volume of this platform, because the same mud is used to make this platform. Okay. So which means both their volume should be same. But volume of the earth dug is in the form of a cylinder. Therefore, volume of cylinder, instead of earth dug I have written cylinder, is equal to volume of the platform. The platform is in the shape of a cuboid. So volume of cuboid. Okay. Volume of cylinder formula is pi r squared h. We use capital R, capital H for the cylinder. Capital R, capital H is equal to volume of cuboid. Formula is length into breadth into height. If you look at this is the cuboid. Formula for cuboid. Volume of cuboid is length into breadth into height. Okay. So volume of cuboid is length into breadth into height. Now substitute values. Pi value is 22/7 into radius is 5 into 5. R squared is there, so 5 into 5 into height is 21 is equal to length of the cuboid was 22 into breadth of the cuboid was 15 into height is what you are going to find. Okay. So let's simplify this. Let's keep the height here on the same side. Take the 22 and the 15 to the left side. So 22 into 5 into 5 into 21 by 7 is already there. The 22 and the 15 go to the denominator is equal to the height of the platform. So let's simplify this. The 22 gets cancelled. 7 and 21 goes thrice. 5 into 3 is 15. So all that is left is 5. So height of this platform is 5 meter. Height of the platform is 5 meter. And your homework for today is exercise 20A, question numbers 17, 19, 18 and 30.